All right. Yes. Yes. Okay. So now we have to classify reactions like this. William, would you help her a minute? Thank you. We have to classify the reaction first before we go anywhere else. We can't go about predicting products till we know what kind of reaction it is. So, well, look at the formulas. What kind of formulas do I have? Who said double? Okay, why do you think it's double? Okay, you've got two-part compounds, A, B, C, D, he says. Potassium carbonate, it's an ionic compound. Aluminum chloride, that's an ionic compound. Metal and a nonmetal, that's one of the ionic compounds, right? Polyatomic ion, that's one of the ionic compounds. Huh? Yeah. Yeah, we said earlier today. The way you recognize ionic compounds from the formula is either you have a metal combined with a nonmetal, or the formula has a polyatomic ion. If I have two ionic compounds, then I probably have a double replacement reaction if one will take place. Okay? So if I have a double replacement reaction, what am I going to write as products? What do I do to predict the products here? Say that again. A with D. So if this is A, what's the D? Cl. So K, Cl. Okay. What's the other part? Well, yeah, C's got to come first. You're right. Cb. So that's aluminum with carbonate. So step one, predict the products. Well, no, step one is classify the equation. Step one, classify the equation. Yes, Aaron? Say that again. Okay. Can I have everybody's attention? Subscripts don't travel unless they're part of a polyatomic ion. This subscript is not part of a polyatomic ion. That's a monoatomic ion. Carbonate is a polyatomic ion. So this 3 travels. Okay? Now so the first thing we had to do was predict the kind of equation or classify the equation. Now we have to predict the products. Now we have to balance the products. Or we can determine the physical state of the products. I like to determine the physical state first, because if I don't have one of these things, no reaction happens and I don't have to do anything else. Yes?
When you say solid water, gas, you mean like a liquid when you say water?
No, I mean, yeah, like a liquid, like the H2O or HOH, yes. Okay? All right. So look on where are you going to find out? First of all, let me ask you this. Do we have water here?
No.
All right. Somebody said there's no water here. Does everybody agree with that?
Yes.
What does aqueous mean?
Dissolved in water.
So if it's dissolved in water, do we have water here?
Yeah.
Yeah, we do. We have to have water here. You can't have, it can't be aqueous if there isn't water. Okay? So, listen. Shh. Solubility rules is what it can do. Aqueous is what it actually does. We want to find out if this is actually aqueous or it's not. And if it's not, it's going to be insoluble, and that makes it a solid. All right. So is KCl going to be aqueous, or is it going to be a solid? How do you know? Well, this is where you find out. Go to your solubility rules and figure out, is KCl a solid, or is it going to be dissolved in water? Soluble means it will dissolve in water, and if there's water, it will be dissolved. It will be aqueous. We're looking for whether this compound right here is going to be soluble. What? Solubility rules? Oh, it's potassium chloride, but we haven't gotten to all of that yet. I didn't say. I'm asking you to find out. I'm asking everybody to get out their solubility rules and figure it out.
No, it's not a solid.
It's a solid. It's a solid.
Why? What? Huh? Where on the activity, on the solubility rules, do you find that potassium chloride is insoluble?
It's not. I mean, it's a
KCl. Okay. All right. So Reese has satisfied my Missouri nature and has shown me why it's soluble. He said it's on the second row of the solubility rules. Chlorides are soluble. If they are soluble, then if there's water, it will dissolve. Okay? But look at the first rule. All group 1 salts. Where do you find potassium? On the periodic table, where is it? That's a group 1 salt then, isn't it? So this is soluble any way you look at it. And since we got water around here, then this is going to be aqueous. Now, determine whether this is going to be aqueous or not. How do you know? I'm from Missouri, you got to show me. Huh? You mean the first rule insoluble or the last one? You say oxides? Shh. Well, this is not an oxide. This is a carbonate. You look on your yes, it is. Okay. Shh. Read the whole rule.
all carbonates and phosphates except group 1 and ammonia.
So, it's got to be insoluble unless it's joined with a group 1 or ammonium. So is this in group 1? Is that ammonium? Then it must be insoluble.
So you don't put anything beside it?
You do put something beside it. If it won't dissolve, it's got to be a solid. Okay? Now I still haven't balanced the formula. How do we balance the formula? Okay, so what oxidation number does aluminum have? Okay, hold on a minute, okay? I'm looking around the room and seeing that about a third of you aren't paying any attention at all. Okay? You are talking about other things and you're playing. And I want you to have fun, but I also want you to pass the test. How much fun is it going to be if you're taking chemistry again? Okay? You're not going to pass chemistry if you don't pay attention. I'm trying to help you understand. No. Amber, you can straighten up and fly right, or you can go to ISS.
I didn't do nothing. I just said
Amber, it's not time to argue.
I didn't do nothing.
Yes, sir, is the appropriate response. Okay. So what charge do we put on aluminum? 3 plus. Where did you find that? Okay. What charge do we put on carbonate? 2 negative. Where did you find that? Okay, it's a common ions list or polyatomic list if you want to call it that. So now I got for a 3 plus and I've got a 2 negative. Okay, so I need to figure out how to get that to be a 0 overall. Okay, so that means I'm going to need 2 of these and 3 of these. So when I write the formula up here, I need 2 of these, 3 of those. Okay? So we do have a driving force because we're forming a solid. We have the formula balanced. We're finally ready to balance the equation. Let's review real quick. First thing we did was to classify the equation. Once we figured out that it was a double replacement reaction, then we flipped the front and back parts around. We put the front part of this with the back part of that and made this compound. We put the front part of this with the back part of that and made that compound. Then we determined whether the physical states were going to give us a driving force. We looked up potassium and chlorides and found they were aqueous. We looked up carbonates and found most of them are not. There's no exception for aluminum, so this is a solid. And because we're forming a solid, that gives us a driving force. We now know the reaction does go forward. Okay, if it wasn't going to go forward, what would we write over here? NR. So now that we got all this done, we're ready to balance the equation. And we use what tool for that? Atom inventory. Okay, so we write down K, C, O, A, L, and Cl. Correct. So carbonates are, well, you got another section down here. This section down here is insoluble. Okay? If it's insoluble, it doesn't dissolve no way, no how. Yeah, so if it's soluble and there's water, it will dissolve. Yeah. Right. You don't have to have both of them form a solid, just one. So that's a good question. I guess I've never had anybody ask that. That's interesting. You don't have to have both of your products be one of these. You only have to have one product be one of these. Okay? That make sense to everybody?
Yeah.
Okay.